So in this video we're going to be looking at rates. We're moving on to a new topic here. Now you're familiar with rates before. Now the basic idea behind a rate is it's a something per something. So one of the most common rates you're probably familiar with is speed. So you're going 50 kilometers per hour. That's kilometers per hour. Now of course with speed you don't have to do kilometers per hour. You could also do meters per second. It doesn't matter what those units are. If it was a very small thing, if it was like a snail that was small and slow, you could measure it in centimeters per hour, perhaps. So these are rates. Something like this, another rate here, is liters per minute. Now you can see that's 1 unit per another unit, 20 litres per minute. So you might turn on a tap and the water's flowing out of that tap at 20 litres per minute. There's also this one down here. You guys won't really be familiar with this too much. 30 kilometres per litre. So that means that your car can travel 30 kilometres on 1 litre of fuel. Now another rate that you may not think about too much, but you probably see a lot, is dollars per kilogram. Now it looks a little bit different to this, but the basic idea still holds. $2 per kilogram. So if I go and buy some bananas, 1 kilogram will cost me $2, 2 kilograms will cost me $4, etc. That's another rate, although people often don't think of it as a rate. Now all of these rates can be graphed in some way. Let's go for a trip in a car, since that seems to be the most obvious rate to deal with. We'll put hours here on the x-axis, and we'll put distance travelled on the y-axis. Now let's say our car in this particular case is going 80 kilometers per hour. At time 0, so after 0 hours, it's not going to be surprising that you haven't travelled anywhere. You've got in the car, you've turned on the ignition, but you haven't put your foot down yet. 0 hours have passed and you've travelled 0 kilometres. Now after 1 hour, it should be fairly obvious, I hope, that you would have travelled 80 kilometres. We can put a little dot there. After 2 hours, you would have travelled 80 plus 80, you would have travelled 160 kilometres. And after 3 hours, you would have travelled 240. Now we can draw a line here that represents this rate. And we can pick any point on that line, and it'll tell us either how long we've been travelling for or how far we've travelled. You can see that. So there's a graphical representation, I suppose, of what a rate really is. Hours, distance, and if you want to know where the speed is actually the amount that the y-axis changes for every 1 unit on the x-axis. So if we go 1 across, it goes 80 up. 1 across and 80 up. So there's our speed. The speed is really the ratio between the amount of up we do and the amount of across it goes. A formula. Formulas are always nice. We're going to use a formula for speed, or for distance really. Very important formula. Distance equals speed times time. Now that's very wordy. Usually it's just written as D equals ST. Now that formula, that's one version of it. So if I knew that I was travelling at, say, 50 kilometres an hour for 4 hours, I would know that I travelled 200 kilometres. Now this formula can be written in 3 ways. We can rearrange it. If we wanted to make T the subject, it would be T equals D over S. And if we wanted to make speed the subject, speed equals D over T. Now these formulas can be used to find either the time or the speed respectively. So let's say I'm traveling 500 kilometers at 100 kilometers per hour. So that's my distance, that's my speed. The time it will take will be 5 hours. And let's say I traveled 1,000 kilometers and it took me 20 hours. So distance, 1,000 kilometers, time, 20 hours. The speed that would take, the speed that you would have been traveling at is 50 kilometers per hour. That's really an introduction to rates. Eventually we're going to start moving away from cars and travel and that kind of thing, and we're going to start moving into some slightly more abstract mathematics with these graphs here on Cartesian planes, x and y axes. But to begin with, let's look at some common rates and do some mathematics that doesn't look much different to this stuff here. Alright, thanks a lot.